Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel for everything I want to talk about, science and math. And today we are in physical science class talking about pH, acids and bases. So let's start. Which one do you think, acids or bases, tastes sour, has hydrogen ions, reacts with metal, turns blue litmus red, has a pH of 0 to 6.9? Do you think that's an acid or a base?
Acid.
Acid, yes. The big clue here is it tastes sour. Now, should you be tasting of things in chem class?
No.
No, we're not going to taste the things. But there are acids you taste of all the time. And in fact, a lot of the food we eat is acids. So these are acids. Everybody write that in. Acids. And notice we have a little lemon over there, so draw a little line to the lemon. So what are some examples of acids? Anybody know? What's an acid that you know of?
Citrus.
Citrus. A lot of fruit is acids. Citric, lemon, oranges. What else? What do you put in your car that's an acid?
Gas.
No. It's not an acid, but there's another place. You don't actually do this. It says, do not open on it. It's a big box under your hood. What's in it? Battery acid, yes. So another one that you might come across is battery acid. We'll call it B acid. It's kind of running out of room. Battery acid. So we're going to do a lab. We're going to look at about like 10 things. And I don't want to give them all away because we're going to test them in lab to see if they are acids or bases. So the definition of it, there are a lot of definitions of acids because acids and bases are something we've known about longer than chemistry. We've known about, lemon juice tastes sour, it's acidic. We've known this longer than chemistry. So an acid was a thing before there was ever chemistry. So there's a lot of different chemical definitions, but the one we're going to go with is it has hydrogen ions in water. So what's floating around in the water are these little hydrogen ions, and the more you've got, the more acidy it is. So there are certain acids, and if it's got more H's back in my chemical stock room, it's going to be a stronger acid. Also, acids react with metal. So has anybody ever had a corroded battery under your car, and your grandpa was there, and he says, "Bring me a Coca-Cola." And he pours it on the battery terminal and gets the rust off. Anybody ever seen somebody do that before? It works. The Coca-Cola is an acid, and it will react with the corrosion on the battery terminal, clean it off, and make it work. So it's one way you can fix your car with Coca-Cola. Another thing is we are going to be testing acids, and one of the ways we're going to do it is with something called litmus paper. It's those little strips. Did I draw them on yours? No, they're on the back. There's some little strips that you're going to put in different chemicals, and depending on how they turn colors, you'll know if it's an acid or a base. And if it's a blue little strip of paper that turns red, it's an acid, and we'll be doing that in lab. And the other thing is how you measure an acid or a base is a number called pH. And for an acid, it's a low pH from 0 to 6.9. There used to be a shampoo commercial that talked all about pH, that you need a shampoo that is pH balanced, that you don't want your shampoo to have lots of base or a lot of acid, you want it pH balanced. And they would run this commercial over and over and over again to where the kids kind of came in understanding pH a little bit, because this commercial would explain it all the time. I don't even remember what the shampoo was. I just remember that it would teach pH in this commercial. Maybe I can find it on YouTube. Everything's on YouTube. All right, so if it's not an acid, our next column is what?
Base.
Base, right. So these are our bases. Now it says taste bitter. Now, what this is, bases, you can think of as soap. Anybody ever been cussing and your mom made you put a bar of soap in your mouth, like in A Christmas Story where he has to have the Lifebuoy in his mouth because he said a bad word? Y'all remember that Christmas movie? Anybody ever tasted a soap? Blech. Tastes bad, doesn't it? Okay, so we are not talking, listen carefully, you'll get this wrong. We are not talking about coffee. Coffee is not a base. Yes, coffee tastes bitter, but that doesn't mean it's a base. Not everything that tastes bitter is a base.
What about a lemon pill?
But all bases taste bitter. What?
A lemon pill?
Lemon pill? If it's lemon, it'd be an acid. It wouldn't be a base. So bases taste bitter. And what makes them a base is they have an OH on them, a hydroxide ion. So just like little H's floating around the water make it an acid, little OH's floating around the water make it a base. Bases feel slippery, just like soap. Think about soap with bases. They react with fats. So how you make soap actually is you take a base, you add it to a fat, and it makes soap. Anybody made homemade soap before? I have. My middle boy has eczema, and someone told me that if I would make homemade soap, it would help his eczema. It didn't. But I have a cousin who I made some for her, and it worked with her. It helped her eczema. But you just take fat, and usually you use like palm oil or olive oil, something like that, some nice oil. You add sodium hydroxide to it, it reacts, and it will make soap. You can make it smell good with like essential oils and stuff like that. But the stuff I made, I didn't put anything in because I was making for people who had skin sensitivity to perfumes and dyes and stuff like that. So I made soap that didn't have anything in it except the base and the oil. And you do it in such a way that has extra oil in it and all the base gets used up. So it's also a moisturizing soap. It's kind of it's a little involved, and the chemical gets really hot. It's super exothermic, but you can make soap. A lot of people do. The other thing is it turns red litmus blue, and you can remember this because base and blue both start with the letter B. So put it in your memory. Base turns things blue. Base turns things blue. And then their pH is from 7.1 to 14. Any questions about bases? This is going very fast. Do you want to try to scroll, Miss Olivier, or do you want me to? So we're going to add to our examples when we get to lab. So examples of base is, the one we use in lab is called lye, or sodium hydroxide. I already told you they're soaps. And we will add some more after we've done our lab. We will do more examples. Okay, so the third thing is in our little drop down here. So if we've got acid and bases, what's the third thing we don't have yet? What if something's neither acid nor base? It's neutral. So what our little drip there is water, as the example, and it's neutral. Neutral. So you've got that little teardrop, and it's neutral. It has no taste. So people say, well, yes, water has a taste, but pure water, if you were to taste, not that you can, but if you were to taste the distilled water I make in lab, it would taste very flat and weird with no taste at all. Our water has like salts in it. It's got chlorine and fluorine. We're used to water having a little bit of a taste, but 100% pure water has no taste. It has a pH of 7.
Is it healthy to drink that?
Is it healthy? Some people say no. There are people who say that the healthiest water is slightly basic, and they sell it now. You can buy it. Bottles of water that say on it that they're basic, and they say we eat too many acids. Most of our food we love is acid, and so they say we should drink water that's slightly basic. I don't, and actually our water, our Paulding County water, if you read their website, is slightly basic. They make it where our tap water is like that fancy bottled water that's basic, because they do that to our water just to make it wonderful. They add base to it, they add chlorine and fluorine. So it's good for your teeth, it has no germs in it, and it's slightly basic for health reasons. Isn't that funny? That they're looking out after us, giving us tap water. So water combines acid and base. So water is H2O, but if you spell it out and separate the H's, it's HOH. Do you see how that's H2O? So it's got it's got the acid part and it's got the base part. So it's both, and it ends up being neither. Water is hydrogen and oxygen. So that's your little blank down there, HOH. I think I filled it in for you though. All right, next page. That was easy, wasn't it? You already knew all that, I bet, right? Pretty much, if you'll scroll for us. Okay, so acids and bases can both be strong or weak. Strong acids and bases are both dangerous. Acids are not more dangerous than bases. It's the strength. A long time ago, I used to teach at Pebblebrook in Mableton in Cobb County, and there are certain cultures where if a girl rejects a boy suitor, okay, you following me? Guy asks a girl out. She says no. In certain cultures, it's considered okay for him to attack her with a chemical and destroy her face and sometimes kill her.
What?
Yeah. I would not recommend Googling it, but it's on the internet where you see pictures of these girls who have survived it, and it melts their faces. It destroys them. So, very glad that when I told guys no on dates, that that's not part of our culture.
These are some of those third world countries where the women don't have rights.
Yeah. So anyway, so this happened in Mableton. So it happened to a lady in Mableton. I guess she was an immigrant. It was part of her culture. And there was a newspaper article written up in the newspaper about it. And it said, acid attack in Mableton. A lady was walking along the road, and this man came up and poured acid in her face and melted her face, and she almost died, and she went blind, and all this kind of stuff. And then the very last line, it says, it is believed that the acid was base. Well, acids aren't bases. Just because it's a strong chemical that can melt your face does not mean it's an acid. It was a strong base. So we're going to talk about, not that I think anybody's going to come up and pour a chemical on your face, but this is happening more in America. There was a lady who was last year, I think, in New York City, did not know the person at all. The person was from another culture where this is considered okay. She was about my age. She goes walking out to go walk her dog, and this random stranger, a terrorist, came up and threw chemical in her face, and it was very devastating. It caused her to go blind. It melted her face. It was terrible. But if something like that happened, once we do our lab, we're going to talk about what you would do to use chemistry to try to offer first aid in that situation. The quicker you can neutralize the chemical, the quicker you can recognize the chemical, the more likely you are to save your eyesight, to save your face, or whatever part of you. Say you're just working somewhere and an acid or a base gets spilt on your arm. What do you do until the ambulance gets there? What can you do to do first aid to help it out? So we're going to talk about that, but not right now because I want us to do our lab first and talk about it. Okay, so strong acids are bad. They can hurt you. Versus weak acids. What makes one strong? We said lemon juice is an acid. If somebody pours lemon juice on your face, it might burn your eyes, but you're going to be fine, right? In fact, I bet you've squirted a lemon before and got it in your face when you were squirting it in your sweet tea before, probably, right? You got lemon juice, maybe got in your eye and it burned, but you were fine. It's because lemon juice is a weak acid. But there are acids like hydrochloric, sulfuric, nitric, that if this gets on you, you are going to the hospital and you might go blind. So what's the difference? The difference is, if it's a strong acid, the chemical comes apart completely in water. It disassociates completely in water. It's more dangerous and it has a lower pH, okay? The other thing we can have is we can have a strong base. a strong base versus a weak base. Soap. Somebody puts soap in your face. It might burn your eyes. It might taste terrible, but you're going to live, right? You get a big squirt of soap in your face, you're fine. But if it's a very strong base, it can kill you. It can kill you. So what's the difference? It disassociates completely. The chemical comes completely apart in water. It's more dangerous, and it has a high pH. Both are dangerous. So there will be a trick question on the test, and it will say, which is more dangerous? A strong acid, B, a strong base, or C, they're both equally dangerous. And what's the right answer? C. They're both dangerous. They're both dangerous. All right. So how can you tell? How can you tell if something's an acid or a base? One way is you can use something to test it, an indicator. Like litmus paper. We're going to do a lab where we're going to use litmus paper, which you probably used before. Didn't you do an acid-base lab probably in elementary school or middle school? Yes? Did y'all ever use litmus paper before? No. A lot of people have. So, but I know, so y'all had a little bit odd middle school experience. Y'all got sent home in 8th grade, right?
Is it just a slip that you dip in?
Yeah, little strips you dip in, they turn color.
Oh, yes. I literally did that like in biology.
You did that before. Well, there's other ones besides litmus. There's one called universal we're going to use. There's a liquid one called universal indicator. We're going to use several different indicators to test and see what's an acid and what's a base. Now, what do you think happens if you combine a really strong acid like hydrochloric and a really strong base like sodium hydroxide? What do you think will happen if I put them together? What do you think will happen? Any guess? Strong acid, strong base. Put them together, what do you get?
A strong acid and base.
A strong acid and base?
Yeah.
No. What else? What else? What's another guess? That was a good guess. Thank you for guessing. But what's another guess?
Wait. What was the question?
You add a real strong acid and a real strong base, what do you think you're going to get? You pour it into one beaker. Strong acid, strong base, what do you get?
Chemical reaction.
Chemical reaction, but what does it make? Do you think it'd be more dangerous or less dangerous?
More dangerous.
It's going to be less. If you add a strong acid and a strong base, like sodium hydroxide and water, you get water, not too dangerous, and salt. You get salt water. So, if someone poured a really strong acid on your face, what do you think you should do? Maybe not do a strong base, but maybe just do a base. So, how do you know? Somebody just poured, you just spilt a chemical on you. How do you know without any lab equipment which one's, if it's an acid or a base? How can you tell? No lab equipment. How are you going to tell?
The touch.
By feeling it. Which one's slippery?
Acid.
The base. Remember, bases are soaps. If it feels slippery, then it is a base. Pour a weak acid on it, and that will help until help gets there. So if you got some lemon juice, pour that on there. We're going to learn other weak acids in lab, and you would just go find one out of your refrigerator and pour it on there. If it was a strong base, that feels slippery. If it feels like water, it's an acid. What could you put on it if someone just put acid on you? What could you do to neutralize it? You could put soap on it. Fast as you can, go get soap and put it on it. And call 911 and wait for help to arrive. Does that make sense? That can save you from a bad situation with a chemical, knowing how to neutralize it. Put the opposite on it and call 911. All right? Okay, so and this is called neutralization.
I can't see it.
Let me write it and we'll scroll up.
I can't see
Will you scroll up?
I can't.
Okay. So that's our notes. What do you think? Is this going to be the easiest test ever?
What is that thing?
Neutralization. If you add acid and base, it neutralizes. They neutralize each other and turn it into salt and water. Much better to have on your face than a bad chemical, right? Like, share, subscribe.